Good afternoon everyone. Myself Harpreet Kaur from GPCG Jalandhar. My subject is microprocessor and topic is architecture of 8085. In this lecture we will cover introduction about microprocessor, then features of 8085 microprocessor, the bus organization, then architecture of microprocessor 8085, pin diagram of 8085, then demultiplexing, low order address bus, that is AD0 to AD7, then generating control signals, then how a stored program is executed in 8085. Introduction. A microprocessor is a multi-purpose programmable clock driven register based electronic device that reads binary instructions from a storage device called memory, accepts binary data as input and processes data according to those instructions and provides results as output. 8085 microprocessor was introduced by Intel in the 1976. This microprocessor is an update of 8080 microprocessor. The 8080 processor was updated with enable or disable instruction pins and interrupt pins to form the 8085 microprocessor. The microprocessor is a semiconductor device manufactured by very large scale integration technique. It includes ALU, arithmetic logic unit, register arrays and control circuit on a single chip. A system designated using a microprocessor as its CPU is called a microcomputer. Features of 8085 microprocessor. The 8085 is an 8-bit general purpose microprocessor that can address 64 kilobyte of memory. It has 40 pins and uses positive 5 volt for power supply. It can run at a maximum frequency of 3 megahertz. It is manufactured with NMOS technology, that is N-channel metal oxide semiconductor technology. It has 16 address bus and hence can address up to 2 raised to power 16, that is 65536 bytes, that is rounded to 64 kilobyte memory locations. The first 8 lines of address bus and 8 lines of data bus are multiplexed, that is both low order address bus is multiplexed time shared. In first few cycles it is used as address bus, after that it is used as data bus. It supports external interrupt request. It provides 1 accumulator, 1 flag register, 6 general purpose registers and 2 special purpose registers. It provides 2 serial input output lines for serial data communication, that is SOD serial output data and SID, that is serial input data. It has 6 8-bit general purpose registers arranged in pairs BC, DE, HL. It is enclosed with 40 pins DIP, that is dual inline package. It provides 5 level interrupts, that is it has 5 interrupts: trap, RST 7.5, RST 6.5, RST 5.5 and interrupt request. It provides 74 instructions. The 8085 bus organization. The 8-bit 8085 CPU communicates with the other units using a 16-bit address bus and an 8-bit data bus and a control bus. Here in this diagram, 8085 microprocessor is shown. In this 16-bit address bus is shown. It will carry memory address. So, the memory capacity is 64 kilobyte and input and output address consists of 8 bits. That is also carried on low order address bus. After that, we have a data bus. Low order address bus and data bus, they are multiplexed, time shared. Data bus is bidirectional, address bus is unidirectional. Then we have control bus. Control bus is also unidirectional. It will carry various control signals for various peripheral devices. The 8085 address bus has 8 signal lines A8 to A15 which are unidirectional. The other 8 address bits are multiplexed, time shared with data bus. So, the bits AD0 to AD7 are bidirectional and serve as A0 to A7 low order address bus and D0 to D7 means data bus at the same time. During the execution of the instruction, these lines carry the address bits during the early part, then during the late part of the execution they carry the data bits. In order to separate the address from the data, we can use a latch to save the value before the function of the bits changes. 16 address lines are capable of addressing a total of, that is 2 raised to power 16, 65536, that is 64 kilobyte memory locations, 64 kilo memory locations. In each memory location 8 bits are stored. So, the total memory capacity is 64 kilobyte. Address locations, that is address map varies from 4 zeros in hexadecimal to 4 FF in hexadecimal. Data bus. It consists of 8 data lines D0 to D7, operates in bidirectional mode. The data bits are sent from the microprocessor to peripheral devices as well as from the peripheral devices to microprocessor. Data range is from 00 in hexadecimal to FF in hexadecimal. Control bus. Control bus consists of various single lines carrying the control signals such as memory read and memory write, etc. Architecture of 8085 microprocessor. The internal logic design of the microprocessor is called its architecture. Determine how and when various operations are performed by the microprocessor. Functional blocks of microprocessor. 8085 consists of various units and each unit performs its own function. The various units of a microprocessor are listed below. First of all, we have arithmetic and logic unit. This unit performs arithmetic and logical functions. After that, we have general purpose registers. We have 6 general purpose registers. Then program counter and stack pointer. These are the 2 special purpose registers. After that, instruction register, instruction decoder, timing and control unit, then interrupt control, serial input output control, address buffer and address data buffer, address bus and data bus. This is the diagram for 8085 microprocessor. In this, various blocks of 8085 microprocessor are shown. Here we have interrupt control, then we have serial input output control, accumulator, then temporary registers, then flag registers, arithmetic logic unit, then timing and control unit, then instruction register, instruction decoder, and these are the general purpose registers. Here we will discuss this diagram in detail. In interrupt controller, it controls the various interrupts. 8085 have 5 interrupts: trap, RST 7.5, RST 6.5, RST 5.5 and interrupt request, and one output signal, that is interrupt acknowledge. Whenever 8085 receives interrupt, it sends a output signal on interrupt acknowledge active low pin. Trap has the highest priority and it is non-maskable. Other interrupts, other 4 interrupts are maskable. After that, we have serial input output controller. It has 2 pins, one is for serial input data and other is for serial output data, that is SOD. Then we have accumulator. Accumulator is 8-bit register. Whenever any arithmetic or logical operation is performed by 8085, one of the byte is stored in accumulator. After the execution of the operation, the result is also stored in accumulator. Flags. According to the results of various operations performed by arithmetic and logic unit, flags in this register are set or reset. In this register, 8 bits are there, but only 5 positions, that is 5 bits are used. Here we have 5 flags: sign flag, carry flag, auxiliary carry flag, 0 flag. Then we have temporary register. It is used to store intermediate data and intermediate results. Then we have arithmetic logic unit. In this, various arithmetic and logical operations are performed. This is the internal 8-bit data bus. From this, whenever instruction is to be executed, it is read from the memory and it comes into instruction register. After that, it goes into instruction decoder. Here instruction is decoded and according to this, various timing and control signals are generated by this timing and control unit. Here X1 and X2, 2 pins. Here the 6 megahertz crystal oscillator is connected and it is internally divided by 2. Operating frequency of 8085 is 3 megahertz. On the 37th pin, we get 3 megahertz output clock frequency. S0 and S1 are status signals which will tell about the type of operation. Then we have one input output oblique memory pin. Here when the signal is high, it shows that the operation is related to the input output device. When it is low, then operation is related with the memory. Read, it is active low signal, and write, this is also active low signal. To read or write, these pins are used from a selected memory location or input output device. Then address latch enable. This pin is used to separate the address and data bus, that is to demultiplex the address and data bus. Low order address and data bus is demultiplexed with the help of this address latch enable pin. Then we have reset in. This is input signal and active high. When the signal on this pin is high, then program counter comes to 0 0, then reset out. This pin is used to reset out the various peripheral devices connected with 8085. Then we have hold, acknowledge and hold pins. These are used with DMA request. Then we have a ready signal. Here we have general purpose registers W and Z. These are temporary storage registers. They all are of 8 bits, BC, DE, HL. These all are of 8 bits, but we can use them in pairs to operate 16-bit operations, to perform the 16-bit operations. Then we have stack pointer, it is also a memory pointer. Then we have a program counter, it is also a memory pointer, it is also 16 bits. Arithmetic and logic unit. In addition to the arithmetic and logic circuits, the ALU includes the accumulator, which is part of every arithmetic and logic operation. Also, the ALU includes a temporary register used for holding data temporarily during the execution of the operation. This temporary register is not accessible by the programmer. Arithmetic and logic unit also includes a flag register. ALU performs all arithmetic and logical operations. Data for all these operations is provided by accumulator and temporary register under the control of timing and control unit. In microprocessor 8085, the ALU is of 8 bit. So, microprocessor 8085 is called 8-bit microprocessor. The different arithmetic and logical operations are performed by microprocessors in ALU are: addition of 8-bit number with and without carry, addition of 16-bit number without carry, then subtraction of 8-bit number with or without borrow, then increment or decrement of 8-bit or 16-bit numbers, then comparison of 8-bit numbers, ANDing, ORing, XORing, inverting of 8-bit numbers, rotation of numbers towards left or right with or without carry. 8085 registers. 8085 has following registers, that is accumulator, then flag register, register B, register C, D, E, H, L, they all are of 8-bit registers. Stack pointer and program counter, these are two special purpose registers. B, C, D, E, H, L, they are 6 general purpose registers. Address bus is unidirectional and data bus is bidirectional. Address bus consists of 16 lines and data bus consists of 8 lines. Low order address bus and data bus are multiplexed. Accumulator. Accumulator is a register which can hold 8-bit data. The data to be processed by arithmetic and logic unit is stored in accumulator. It also stores the result of the operation carried out by arithmetic and logic unit. The accumulator is connected to internal data bus and ALU, arithmetic logic unit. Flag register. In flag register, bits are affected by the arithmetic and logic operations. There are 5 flags in 8085. The bit positions reserved for these flags in the flag register are shown in the figure below. At D0 position we have carry flag, at D1 is unused, that is for future use, D2 parity, D4 auxiliary carry, D6 zero flag, D7 for sign flag. These are the bit positions of various flags in flag register of 8085. Sign flag. The sign flag is set if bit D7 of the accumulator is set after an arithmetic or logic operation. Auxiliary carry. This flag is set when a carry is generated from bit D3 and passed to D4, that is from the lower nibble side. When carry is generated, then this bit auxiliary carry is set. This flag is used only internally for BCD operations. Then we have parity flag. After an ALU operation, if the result has an even number of ones, the parity flag is set. Otherwise, it is cleared. So, the flag can be used to indicate even parity. Carry flag. It is set if there was a carry during addition or borrowed during subtraction, comparison, rotation. Zero flag. It is set if the result of the arithmetic logic unit operation is 0, otherwise it is reset. If any result comes 0, then this flag is set, otherwise it is reset. General purpose registers. 8085 has 6 general purpose registers, that is B, C, D, E, H, L. They all are of 8 bits. They can also be combined as register pairs to perform 16-bit operations, that is as BCE, DE, HL. Registers are programmable. We can load the data and move the data in these registers. Then we have program counter. This is a special purpose register. This is 16-bit register, deals with sequencing the execution of instructions. Memory locations have 16-bit address, and that is why this is a 16-bit register. The function of program counter is to point to the memory address from which the next byte is to be fetched. When a byte is being fetched, the program counter is incremented by the 1 to point to the next memory location. Program counter is incremented by 1 to point to the next memory location. Then we have stack pointer. Stack pointer is also a 16-bit register used as memory pointer. It points to a memory location in read-write memory called the stack. The beginning of stack is defined by loading 16-bit address in stack pointer. The beginning of stack is defined by loading 16-bit address in the stack pointer. Then instruction register. This is not accessible to user. CPU fetches the instruction from memory and loads it into instruction register. One thing should be remembered clearly, that only opcode is placed in instruction register. Opcode means operation code. After this, opcode is provided to decoder for decoding. Instruction decoder. We know that before executing any instruction, microprocessor decodes the instruction. The opcode holds the information that which type of operation is to be performed by whom and how. All this information is received after decoding the opcode by instruction decoder, which it receives from instruction register. Timing and control unit. This unit receives the decoded signal from instruction decoder and generates various control signals to execute the instruction. timing and control unit provide status signals, control signals and timing signals which are necessary for any operation of memory and input output device. Timing and control unit provide status signals, control signals and timing signals which are necessary for any operation of memory and input output device. It is not only generate these signals, but also perform sequencing and synchronizing operations. Timing and control unit controls the whole operation of microprocessor and input output devices. It is like the brain of microprocessor. It is like the brain of microprocessor. Timing and control unit is the brain of microprocessor. Then interrupt control. Interrupt is a request from input output device. On getting interrupt, CPU completes the present instruction and then attend the interrupt request. 8085 has 5 hardware interrupts: interrupt request, RST 7.5, RST 6.5, RST 5.5 and trap. Trap has RST 4.5. If 2 or more than 2 interrupts comes simultaneously, CPU will execute in term of priority. Trap has highest priority, then after that RST 7.5, RST 6.5, RST 5.5 and at last interrupt request. This unit control serial input output control. This unit control the transfer of serial input output data. The SID input is used where the data serially enters 8085. Serial input data, and SOD serial output data is used where the serial data leaves 8085. The RIM read interrupt mask and SIM set interrupt mask instructions are used in 8085 for serial data transfer. Then we have pin diagram of 8085. 8085 has 40 pins. First of all, we have X1 and X2. These are the terminals connected to an external crystal, LC or RC oscillator. These pins are used to drive internal clock generator which produces suitable clock for operation of microprocessor. Generally, a crystal oscillator of 6 megahertz frequency is used, but the operating frequency of 8085 is 3 megahertz. So, that is why it is internally divided by 2. Then we have reset out. Reset out is an active high output signal. It indicates that the CPU is being reset. This signal is used by CPU to reset other devices connected to it. Then we have reset in. Reset in, it is an active low input signal at 36th pin number. It sets program counter to 00, resets the interrupt and enable, then hold acknowledge, etc. The CPU is held in reset condition as long as signal at this pin is kept low. After that, we have serial input data and serial output data, SID and SOD. Serial input data is an active high serial input port pin used to accept serial 1 bit data. Serially 1 bit data. On the execution of RIM instruction, this data is loaded into the 7th bit of the accumulator. Then we have SOD, serial output data, is an active high serial output port pin. This pin 1 bit data is serially outputted. SOD pin is used to set or reset depending upon the accumulator's D6th and D7th bit after the execution of SIM instruction. After that we have interrupts trap RST 7.5, 6.5, RST 5.5, interrupt request, then interrupt acknowledge. Trap has the highest priority. Then after that RST 7.5, 6.5, 5.5 and then interrupt request. After that we have interrupt